Alright, so we're going to work with fractions again, but what we're going to do is we're going to add and subtract fractions. So let's give you a basic one. Now, we talked about the calculator before. People say all the time, because I try to teach students in my algebra classes and my geometry classes and all these to make sure that you don't just use your calculator to add up fractions and subtract fractions. For instance, if I had like 3/4 plus 5/7, if I had something like this, most people would just gravitate right to the calculator. All right, but you should know how to do this without using a calculator, because the stuff that we're going to do in this lesson, you're not going to be able to do in your calculator. Because people tell me all the time, well, why do I have to know how to do this? Because I know how to do this in my calculator. Why can't I just use the calculator? Well, a good reason is because you're not always going to have just numbers here. A lot of times in your math classes, especially when in Algebra 2 and further on, you're going to have to add fractions that aren't just regular numbers. They're going to have variables. They're going to have exponents. They're going to have all kinds of crazy things on there, and you're going to have to know how to add those fractions without using a calculator. And if you can't add this together without using a calculator, you'll never be able to add the stuff that we're going to do here in a few minutes without a calculator. All right, so what we're going to do is this. Now, there's different ways that people show how to add fractions. I'm going to show you the way that works for me. All right, and if you want to try it, it's not really another way, but it's just how we write this down. So what I'm going to do is this. Instead of writing, a lot of people, back when you first learned to add fractions, you would do this stuff up and down. Remember that? It looks like this, like 3/4 plus 5/7. Remember that? You put a big thing here, and then you find a common denominator right here and here. Remember that? I'm not going to do that, because algebra, that's not very practical when we add fractions in algebra. So I'm going to do things across when we add fractions in algebra. Okay, I just think this has worked well for me, so I think it might be okay for you too. Now, what do we have to do? We got to find a common denominator. I got 4 and 7. What was your common denominator? What's the lowest? Remember, lowest common denominator, LCD. All right, find the smallest number that 4 and 7 both divide into evenly. And if you get stuck, you can always just multiply those two numbers together, can't you? And in this case, it's just 28. I just make one common denominator. Some people would separate it into two separate fractions. That's okay, but I just like to make one common denominator. But what do you do to find your numerators, though? You take that 4, and you have to ask yourself this question. And we'll be doing this for every problem that we do here. What did we do to 4? What did we multiply 4 by in order to get to 28? 7. Now, some of you might want to do this, okay? Times 7 and then times 7. All right, you're kind of used to that when you did fractions when you first learned how to do it. But at this point, you might just be able to do this in your head. 4 times 7, 3 times 7. But if you want to put the times 7 there, feel free to do that. If that's a helpful thing for you, by all means, go ahead and do that. Sometimes I'll just do it on the top, okay? 4 times 7, 3 times 7 is 21. And then plus, what's this? 7 times 4. So 5 times 4 is 20. And now you can just add them up. You already got that one common denominator. So what's that? 41 over 28. And I'm perfectly fine if you just keep it like that. I'm not requiring that you make it a mixed number. You can keep it just like that. All right? So that's adding fractions. That's adding fractions with, just by doing it by hand without using a calculator whatsoever. And we didn't need a calculator for that. Now, we could have used one, right? I mean, to get that answer, if you know how to use the calculator or the fraction buttons on your calculator, you could have actually got that answer. And nowadays, the calculators give you answers as fractions. Back when calculators first came out, the handheld calculators, they really couldn't work with fractions very well. But now they've upgraded them, and they're very good with fractions, and you can do a lot of things with fractions. You could take that improper and make it a mixed number just on your calculator. Okay, you can do all kinds of cool things. But that's not really going to help us for what we're going to do here. Watch this. What if I wanted, now this is as basic as it gets. In fact, they even put this in a box, okay, in the bottom of page 47. If you want to write that down. What if you want to add these together? Now, would you be able to put that into a calculator and get an answer? No, you wouldn't, okay, because they're not regular numbers, okay? They're variables. They stand for numbers, but we don't know what those numbers are. But we still need to add those two fractions together. There's many times in math where you have to add things together, and you don't know what the numbers are. They're all variables. There's a lot of times in math where you have to do that. So what do we have to do? We have to find a common denominator. Probably shouldn't erase that other thing I did. I should have had it up here as a guide, but you have it in your notes. You didn't erase it. So you got to find a common denominator. All right, so yeah, so remember what we did to find that common denominator? You can just multiply the two things together. Find a least common multiple, or least common denominator, some people say, BD. So I put a BD right there. All right, now what do we do to the top? What did you multiply B by to get this? Multiplied it by what? By D. So you come over here and you multiply the top by D. Right? It's following the same exact steps, isn't it? It's what we did before. So this is AD. Now, what'd you do to this D to get to this? Multiplied it by what? By B. So what do you do to the top? Multiply that by B. Now, I could put the B to the right of it, but I don't know. I kind of like it in alphabetical order, so I'll put plus BC. And that's it. Can you add AD plus BC? No, you can't add them together, so that's all you can do with it. And that's your answer to that addition problem. Now, it seems like this stuff really doesn't have any meaning. You know, where are you ever going to use this stuff where you add stuff and you don't even know what the numbers are, okay? And you're absolutely right. This in and of itself isn't really going to help you. This is just a stepping stone in order to do things else, something else. A lot of you guys play sports. You might be in the band, or you might be musical or something like that. You got to start somewhere. I played a lot of instruments, several different instruments, and playing piano, playing trumpet, and things like that. We had to learn our scales, right? Now, are you going to get in a concert and just play the whole entire C scale up and down about 3 or 4 or 5 times? Are you going to play arpeggios up and down 3 or 4 times? No. But what is it? It's a practice for what you're going to do in the big game, the concert, okay, or whatever you're going to do. So you have to learn skill sets in order to do something for the big game. Artur, you're a soccer player in Mexico. Did they make you do juggling the ball? Did you have to juggle the ball a lot in practice? You probably don't do that too much here, though, do you? But Arturo's got incredible ball control, and it's probably because you can juggle the ball. Do you know what I'm talking about, juggling? You know, you bounce it off your legs and stuff like that. Do you know how many times, you ever counted, like, how many times you've juggled? When I was at William Penn, I was on the soccer team, and in order to make the team, in order just to make the team, we had to juggle at least 100 times. And some people like, 100 times? Wow, I'd never be able to do that. But that was like nothing. There was a kid, I was on JV when I was at William Penn. I was in 10th grade, and they brought one of the seniors over, and he was all-state soccer player, just fantastic. He came over, and the coach said, Johnny, he says, show us how to juggle on your head, right? What he did, no lie, he had the ball, and he's a regular American dude. He wasn't a foreign exchange student or anything, right? He grew up in the States, but you know, but he practiced and practiced and practiced all the time. He put the ball in his head. We stood around in a circle and just watched him. No lie, we counted 400 times on his head without dropping it, without hitting his legs, without hitting his feet. 400 times. No, he was standing up. He was standing up, had his head like this, and he would just bounce it, boing, 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 off the top of his head, 400 times. Now, is he going to? My point is this. Long way to get to the point. My point is this. When you get to the game, is he going to sit there and juggle it 400 times on his head in the game? No. But you know what he might have to do? He might have to pass it, right, with his head, you know, maybe once or twice or 3 times a game. But he's got so good ball control with his head that he could put the ball anywhere he wanted, you know, with a pass. He's not just heading it just to head it. I mean, he can put it on a dime because he had so much ball control, because he practiced the little things. It's like this. This is the little thing. This is juggling the ball on your head. This is doing your scales when you're playing piano or trumpet or whatever instrument you're playing. That's what this stuff that we're doing is. It's preparing us for, quote, the big game, all right, for stuff that really you use, like in physics. I taught physics for a lot of years. Has anybody taken physics this year? Nobody in here is taking physics at all? Got 1, 2, okay. You're gonna use a lot of this kind of stuff in physics. You're gonna have to manipulate equations. You're gonna have to add things together, and they're gonna be variables. You're gonna take these equations with tons of variables, and you're gonna have to do things with it. How are you gonna be able to do that in a real practical physics class if you can't do stuff like this? Okay, that's my whole point. So I think it's important to learn this stuff, not just for now. You're not gonna go out and get a job and say, hey, I can add these fractions together, and there's not any, you know, without a calculator, and there's no numbers here. No, you're not going to get a job that you're going to do something like that, but it's a skill set that you're trying to learn, okay? So just kind of keep that in mind. All right, let's do an example. 5 over 9x squared plus 1 over 6x. Alright, and we're just going to add these together. We'll just say add the fractions. So, first thing we need to do, we'll keep this up here. First thing we need to do is find a common denominator. Okay, I'm going to put it over just one denominator. You could separate them into two if you wanted to. But let's look at 9 and 6. Alright, let's think how to find the common denominator with 9 and 6. Let me show you a little shortcut. Now, you might be able to do this in your head, and I'm sure you could. Alright, but let me just show you a little shortcut, because when the numbers get a little bit bigger, a little more complicated, this is a nice, easy way to do this. What you're going to do is you can take those two numbers and break them down into their prime numbers. So 9, let's break it down as far as we can. That's easy, 3 times 3. Let's take 6 and break that down. 2 times 3. Alright, everybody with me on that? They're all prime numbers now. So what we're going to do, I've got two sets of prime numbers, right here and right here. So what I'm going to do is take a number that shows up in either one of them. Alright, and if it shows up more than once, I'm going to take the one that shows up the most number of times. For instance, what number shows up between these two columns? I'll split it like this. The 2 shows up, right? It doesn't have to be in both places, alright? It just has to show up somewhere. So I'm going to pick a 2. So I'm going to pull out a 2. I'll even circle it. Alright? Now, a 3 shows up here twice and here once. What did I say just a second ago? We picked the number that shows up the what? The most number of times, okay? So it shows up here once, it shows up here twice, so which one do I pick? The ones that shows up the most number of times on that side. So I'm going to go 3 times 3. Now it seems a little bit like a long way to go for 9 and 6, and it probably is, but I picked easy numbers just to show you how to do this. Sometimes the number is going to be a little bit longer, a little bit bigger, a little more complicated, but this is a nice way to find the least common multiple, okay? So now I just multiply these together. Okay, 3 times 3 is 9, times 2 is what? 18. Alright, and that's our least common multiple, or common denominator. Make sense? Alright, you can go back and look and see what I did there. We'll try that a couple more times if they give you numbers a little bit bigger, a little bit harder to deal with. What's that? Yeah, let's take a look at the x's. The same thing really applies with the x's. I've got an x squared and an x. Well, how many times does x squared show up? Or how many times does x show up over here on the left? Twice, right? And it shows up here once. So if it shows up in both places, we take the one that shows up the what? The most number of times. So which one shows up the most number of times? The x squared, right? So I go x squared. So really the same process works with the x's and the variables and the exponents as does the numbers. Does that make any sense at all? So that's kind of a nice way to think about it. Excuse me. So that right there, that's the smallest number that each of these divides into evenly. All right, so this divides into this evenly, and this divides into this evenly. And that's our least common multiple. That's really the hardest part, I think, of doing these fractions. Now, let's figure out what our numerator is going to be. So what did we do to this in order to get to this denominator? What did we do to the 9? What did we multiply the 9 by? By 2. So what do we do over here? Multiply, that's supposed to be multiply, by 2. What about the x squared? Didn't really do anything, did we? It stayed the same. Multiply by 1, technically. So all you have to do is multiply by 2 right there. Does that make sense? So let's figure out what our numerator is over here. 5 times 2 is 10. Plus. Let's do the same thing with the other denominator. What did we multiply 6 by in order to get this 18? Multiplied it by 3. So what do we do to the top? Multiply that by 3. What about the x? What did we multiply x by to get? We multiplied it by an x, not by a 2, because 2 would make it 2x. We multiplied it by an x to get x squared, didn't we? So I got to multiply the top by an x as well. Alright, it's the same process as just regular numbers, isn't it? It's a little bit more complicated, but it's basically the same process. We multiply those together and we get 3x. That's all we can do. There's nothing else you can do. That's your answer. So you added up those fractions. Nope. No, because we only multiplied by a 2. We only took this and we multiplied it by a 2 to get to this. Alright, so you only multiply the top by a 2. So it's just 5 times 2, and that's just a 10. And then what'd you do to this whole thing right here? You multiplied it by what? A 3x. So you multiply the top by a 3x. And 1 times 3x is just 3x. That's all there is to it. Let's try another one. You know they're going to get tougher than that, right? Let's do this. Y plus 2 over y squared minus y minus 3y on top, and then 2y squared minus 4y plus 2. Alright, look at this crazy thing. Look at the bottom. That's a mess, isn't it? But what does it possibly look like we can do? There's nothing really that's being multiplied together, is there? I mean, it doesn't look like it. Like right here, it's just 9x squared, and that's it. But look at this. I got a minus in between, and minus here, and a plus here. Alright? Gabby, what'd you say we can do? Yeah, let's factor it out. That looks like one of those problems we can factor. We just worked on some problems from that homework, didn't we? On factoring, so let's do that. Let's factor the bottom. Let's see what we get. Let's keep the top the same. There's nothing really I can do to the top anyway. Let's factor the bottom. Well, I got a y in common, and so I factor out a y. I get y minus 1. Okay, don't forget to put that 1 there. On the quiz, a couple people forgot to put the 1 there. Alright, because if I'm dividing this by y squared divided by y is y. Y divided by y is 1. You got to have the 1 there. Minus. Alright, let's do this one. This looks like a trinomial factoring. So and we got a 3y on top. Let's figure out what the bottom is. Let's factor this thing. This is what I'm doing. I'm looking at this thing right here, and I'm trying to factor it. And this is, again, something that we've done before. We had a whole lesson on it. We had a quiz on it and test on it and everything. So we've got 2y and y. Let's try signs. Let's go negative and negative, because when they multiply to be positive and they add up to be a negative. 2. Let's go. We could go 2 and 1. Let's go 1 and 2. Let's see if that works. No, that's not going to work, is it?
Other way around.
Okay, let's try. Let's trying to outsmart myself. Let's try that. Is that going to work?
Yes.
Yep, the outside is negative 2y, the inside is negative 2y, and adds up to be negative 4y. Good, so that's our factoring right there. So you look at this, you can say, well, that's still, oh, let's factor out this. Oh, yeah, oh man, I should have seen that right off the bat. What should I have done right off the bat? I noticed it right here, and when Tiffany started saying, I'm like, oh, what did I miss? Yeah, greatest common factor. You probably should have factored out a 2 first, and then you could have factored this, okay? But we can still do this, because we can still factor out a 2 from this thing right here, can't we? So if I factor out a 2, what am I going to have? Y minus 1, correct? Alright, so let's just rewrite this.
Y minus 1 squared.
Yeah, we could write it as a y minus 1 squared as well, couldn't we? Because it's this, right? And then what? Because when I factor out a 2, I had to divide those both by 2, so 2 divided by 2 is 1. So you could just write this as y minus 1 squared, couldn't you? Alright, so let's go ahead and do that. And let's just scooch this over a little bit, just so it's underneath. Alright? Now, does that help at all? I don't know, maybe you're looking at this and you're saying, it's no better than what it was before. But let's think about this. How in the world do we find a common denominator? I'll tell you what, instead of going across right here, it's a little bit long, so I'm going to put it down here. What are we going to do here? Well, let's find out what shows up in both of these columns. Do you see that? I've got this denominator and this denominator. Let's take a look at the numbers first. Are there numbers that show up in the bottom? There's a 2, right? So I'm going to pick a 2. What else shows up that's being multiplied here?
Y minus 1.
Yeah, oh, but let's do just, before we get to the parentheses, let's do this. It's a little bit better order if we do the y. There's a y that shows up. It only shows up once, doesn't it? Now, you're looking at me, you're thinking, no, it doesn't. There's a y right here. But remember, this is acting as one complete term, right? There's just one y by itself. Yep, so I'm going to put a y right here. Now, look at this. I have a y minus 1 on this side. I got 2 y minus 1s over here, don't I? Which one do I pick? If it shows up in both places, I pick the one that does what? Shows up the most number of times. So which one shows up the most number of times? The y minus 1 squared. All right, so that's my common denominator. All right, kind of looks like that, except we stuck another y in there, didn't we? And it kind of looks like this, except we put a 2 and a squared here. But that's how we find the common denominator. Okay, what we did with that 6 and that 9, that works a lot. It even works for this kind of stuff. So that's the hardest part about this whole problem right there, what I just did. I mean, it takes a little while to understand that. Go back to the video and look at it if I went a little quick on this. So now what do we have to do? We got to figure out what our denominator is going to be. So what did we do to this? What did we multiply this by in order to get this denominator right here? Yeah, we multiplied by a 2. All right, so let's put this in parentheses. So we had to multiply by a 2. What else did we had to multiply it by? Not a y, because it already had a y in it.
Y minus
A
1.
y minus 1, that's right. So I had to multiply it by y minus 1. You see that? So now I'm going to write all that stuff down right here. So I'm going to write 2, and then y plus 2, and then y minus 1. See what I'm talking about? You could never do this on a calculator? There's no way. Alright? Now let's keep going. Put a minus right here since we have a minus there. And then let's figure out what we had to do. Let's see what color. I want to go to this color again. What do we have to do to this to get to this? Well, it already has a 2 here. It already has a y minus 1 squared here. What's it missing? A y. So really all I got to do is multiply the top by a y. See that? That's right. See, all I had to do was multiply this by a y to get to this. Because what's missing? It's already got a 2. It's already got a y minus 1 squared. What's it missing? It's missing a y. Right? So that's why I multiplied it by y. So would you multiply this by? A y. So you do the same thing to the top. Make sense? All right. So let's write that down. It's just 3y squared. Now, it's probably not the nicest way to write that answer. Let me just see how they write it. Yeah, it's probably not the nicest way to write the answer. What do you think you might want to do with this? Well, you can't cancel stuff out right here because you got this minus in between. Okay? So a lot of that stuff that we learned earlier, you've got to apply here. I'll give you a helpful hint. The denominator, we'll just keep it looking just like that. But if there's stuff that you can multiply on top, so you can multiply those together, FOIL it, right? Let's go ahead and do that and multiply it on the top. We won't worry about the bottom. We'll just keep the bottom exactly the way it was. So let's take the top, multiply that stuff together. So I've got a 2. And what's this? Y plus 2 times y minus 1. Let's multiply those together. FOIL method. So it's going to be y squared. The outside is minus y. The inside is plus 2y. So that's a plus y. All right? Go back. If I'm going fast, go back and watch it. Then minus 2 minus 3y squared. And the bottom stays the same. That doesn't change. We're almost done. What do we have to do here? What do you think we can do here? It's not factor.
Multiply.
Distribute. Right. Multiply everything by 2. This parentheses right here. Distribute the 2 through this. Alright, so let's do that. So it's going to be 2y squared plus 2y minus 4. And then stick that minus 3y squared on the end. Again, it's all over this. One more step and we're finished. You can add some like terms together, can't you? So let's add those together. 2y squared minus 3y squared is negative y squared. And then plus 2y minus 4. And then the bottom stays the same. I just keep writing the bottom exactly the same. And then that is your answer. Pretty crazy, huh?
Crazy's a mild way.
Just because it's just kind of nice to see what your denominator was before you multiply it all out. Just kind of the way that they write it. We'll just say it that way. I don't think there's any real practical reason. I guess there kind of is. Yeah, but they don't make you do it, so I wouldn't do it. Okay, it's too much work. So when you get the bottom to be your common denominator, I would just leave the bottom like that. Okay, don't even mess with it. It's the top that they want you to simplify. Alright, so we simplify the top, leave the bottom the way it was, and then we're good to go. So that's the answer that they have in the book. Alright, and that's the answer that you'll have when I read them off and you do these problems. Alright? That's pretty much it right there. So that means, let's see which numbers you should be able to do now. You should be able to do 10 through 15. Alright, so all that stuff right there is number 10 through 15 on that worksheet. I guess I could have made like 3 separate worksheets for this, but I stuck it all in one worksheet. We'll just do little bits at a time. Is that alright? Because that's a lot of stuff to teach in one class. Even if I started right from the beginning, didn't review any homeworks or anything, there's just no way I could teach all that stuff in one class period. So just do 10 through 15, and I guess that won't be due till what? Wednesday, right? Because you don't have school Monday and Tuesday? Lucky you. I'm still here. So enjoy your long weekend.